Great pleasure to be with you this morning, although I would much rather be with you in person, as we all would rather be joining each other. And hopefully before too much longer, we'll have that opportunity to get back to some semblance of normal. Let me go ahead and get my laser pointer going here so that I've got it for later on. Kim and the crew there at Michigan have asked me to give a little bit of an update from the Dairy Forage Research Center and talking a little bit about our history and our future. It's really my pleasure to be able to be the center director here. I am so proud of the accomplishments that our center have made over the years. And I'm really excited about the future because as you'll see as we go through here, we're in a growth phase, and I think we are really poised to have some major impact and continue the legacy that the Dairy Forage Research Center has brought to the industry. Speaking of that research legacy and impact, I would bring to your attention here, and let me see if I can actually bring open the chat box. And I'm going to send that YouTube link via the chat box. If you are so inclined, would like to listen to me a little further about the history of our center and the impact that it's had over its 40 years, I'm going to give you a little bit of a preview of some of that. But the history, I think, is really kind of a great story. And actually, Michigan State was a part of that history early on. In the early vision of the center, it was actually envisioned to be a collection of satellite locations across the upper Midwest and Northeast. And of course, as politics change, things, funding avenues change, et cetera. But man, we've had such a great impact over the years, and really those collaborations still exist. And I'll talk a little bit about some of those collaborations as we go through. Our vision at the Dairy Forage Research Center is to lead the world in integrated dairy forage research systems. I want to really highlight a few of those keywords, and obviously dairy and forage are at the heart of what we do, but integrated is really what I want to bring to the forefront here. The integrated nature of what we do is unlike most anywhere else in the country, because we are able to bring in experts that are really experts in their field, specializing in the forage aspect, the nutrition aspect, and the environmental aspect, and then all of those kind of bits and pieces that fit into that. I mean, we have soil scientists, we have chemists, we have folks who study pathogens and the impact of the dairy industry with regard to pathogens getting into the environment. There's a large number of projects that are involved here, and all of these things tend to interlink. And so we bring together those disciplines to focus on this particular project or this effort in a very integrated way. You know, I spent a career, 20 years in academia, first at the University of Kentucky and then at the University of Georgia. And, you know, there are disciplinary focuses within those universities just because of the way they're structured around teaching, which is, you know, that's really the appropriate way of handling it. But our center really brings all those disciplines together. We get rid of the disciplinary lines. We really are focused on the research effort as a team. And we call ourselves the Team Dairy Forage, and we really focus on that integrated aspect. And there's a necessity for that. If you think about the complexity of the dairy system, from the soil all the way through the animal and back to the environment, there's a cycle there that requires a lot of integration. Now, our center is actually divided from a hierarchical standpoint. We have to kind of divide these up for funding streams to come in. And so the cell wall biology and utilization research unit is one of our research units. Then we have the dairy forage research unit, and then the environmentally integrated dairy management research unit. So if you hear me referring to each of those three, what I'm really referring to is the focus that each of those bring. So, for example, the cell wall unit is really more of a basic science. It's focusing more on understanding the dairy animal and the forage from a physiological standpoint. Uh, we have scientists that delve deeply into the chemistry of the cell wall makeup and some of the cell compounds, the plant compounds that are there, down to the very molecular level. And then we have the Dairy Forage Research Unit that brings that information together in a very applied way, down to the point of really focusing on how do we grow better forage, how do we develop better feeding systems to overall increase the efficiency of the dairy enterprise. Then the third one really focuses on environmental science and how to reduce the environmental footprint of the U.S. dairy industry. So that's the tripartite, the three-legged stool here of how we approach our research. That's how we bring all those together and kind of begin to, work on each of those individual aspects. Now, as of this very moment, we have 9 scientists in the cell wall unit. We have 8 scientists in the dairy forage unit and 5 scientists in our, what we call the Marshfield unit. The Environmentally Integrated Dairy Management Research Unit is located in Marshfield, Wisconsin, which is about 2.5, 3 hours north of Madison. Even though they're at some distance from us, we are very integrated with them and have a lot of research both at Madison and Prairie du Sac as well as in Marshfield from that unit. Now, to broaden that those themes a little wider so you can kind of see some of the elements of how we weave all these together. These are some of the functional groups that we have within the center. We have a group focusing, for example, on soil health and ecology, a group focused on breeding. We have a grass breeder and legume breeder. Many of you are probably utilizing some of those varieties and maybe not even realizing that you're doing so. Then we have folks who are focusing on the rumen ecology and the microbiome of the rumen and understanding the linkage between the animal and the microbes. And it's a real true symbiotic relationship there. And they play off of each other. And then, of course, we have the environmental aspect, looking at not only manure and nutrient management, but also looking at dairy emissions, greenhouse gases, pathogens, biologically active compounds, et cetera. So it's a wide and varied look at the integrated dairy forage enterprise. Now, a lot of our researchers and our research you may not be familiar with on a day-to-day basis because a lot of it underpins much of the work that's out in the real world. So, for example, if you've taken forages as a class at Michigan State or one of the other land-grant universities, more than likely you've come across one of these textbooks, for example. And our scientists have been key authors of some of those mini chapters. I believe Kim actually has got some material in here as well. And, these are the fundamental things that are at play that kind of undergird the extension recommendations that come out of your land-grant university or that come out in some of the guidelines from throughout the industry. One of the key things that our center became known for is understanding forage digestibility and understanding how the structural aspects of that plant really influence the digestibility of the forage. And that's where we're getting most of our energy, of course, in those ruminant diets is going to be from the fiber that is being digested there. And so understanding those kinetics within the rumen, researching avenues to be able to manipulate lignin really gave rise to in Congress with the Noble Foundation at the time and Forage Genetics International. That's what gave rise to Harvextra as an example. And again, writing a lot of the background reference material. This textbook on forage cell wall structure and digestibility is a reference item for many of our forage nutritionist, forage agronomist, dairy nutritionists around the world. That's a fundamental aspect of how we understand how we feed animals. And books like Dietary Sugars, we have scientists who have contributed to that as well. Then from a protein standpoint too, we also need to understand how that is influenced by the rumen. And so better understanding of protein degradation within silage and in the rumen has been one of the focal points of our scientists over the years, and better understanding of peptide absorption, how microbial protein, it's mostly that protein that's the nitrogen is acted on by the microbes, and those microbes are then further digested in the abomasum of the rumen animal, and therefore we get a lot of our protein in the rumen system from microbial protein. And then more recently, we've been better understanding methionine supplementation in dairy diets, and that has really moved the ball forward in improving protein efficiency, nitrogen use efficiency within the dairy industry. And this has led to refinements in the NRC, for example, and some of the basic textbooks that are used in training the next generation of scientists. Which, by the way, I understand that later this year, the newest edition of the NRC for dairy cattle will be released, and Dr. Mary Beth Hall is one of our scientists who's very much engaged in that process. We've also worked very strongly on better assessment methods and metrics for forage quality, and refining some of the analytical techniques that we use for determining forage digestibility and forage nutritive value in general. And our center, as part of its history, was one of the key players in developing the Nirs Consortium. And that is really the birthplace of the standard equations that many of our forage labs use. So again, you may not be realizing that the Dairy Forage Research Center was at play here, but that really, every NIRS based forage test that you might get back, almost all of those are going to be influenced by some of the work that those scientists did in the early days of developing NIRS and replacing some of these wet chemistry methods with a more sophisticated and time efficient and cost efficient method of NIRS based analyses. So that gave rise to, again, more reference materials, lots of publications and writing, and then the development of the Nirs Consortium, and fostering also the standards that are put out there in the industry from the National Forest Testing Association. We've also had a lot of hand in improving silage making. Rich Muck, who's pictured here, was a longtime researcher at the Dairy Forage Research Center, focused on silage making, along with many colleagues at the University of Wisconsin and elsewhere. Really was one of the key players in improving silage making. And if you start looking at the long list of textbooks and reference materials of which our scientists have participated in, which, by the way, on our website, there is a list of all of the different publications and all of the different books that our scientists have co-authored in. It's a pretty extensive list, and it's really the most important reference materials within our discipline. Our scientists are all over those. I also want to highlight the fact that we do work a lot in grazing, and historically we've worked a lot. I know you probably have heard from Dr. Jeff Brink over the years, who recently retired, and Mike Kassler, who is our grass breeder, and he really focused on bringing a lot to the grazing environment. Heathcliff Ride is a legume breeder with our center. Wayne Koblentz has done a lot of work with baleage, and as well as with grazing. And in my baleage talk this afternoon, you'll see quite a bit of data from Wayne's program over the years. And we're just filling now a position in Marshfield to further our efforts with grazing. We've been able to add a position focused on heifer development and grazing systems, and we're really excited about being able to continue this grazing work into the future. So We also focus on improving cool season grass productivity and persistence for pastures. Um, uh, we focus on research that looks at grass physical and quality characteristics that influence pasture intake. Um, Also have some studies that have been looking at residue height, and we all know that grazing residue or grazing residual height has a huge influence on the regrowth rate, and as well as tiller count and stand thickness, uh, productivity, quality, persistence. It influences a lot of different things. So this is a picture of some research at our location in Prairie du Sac, where they've been doing quite a bit of grazing research there over the years as well. But I want to highlight that in addition to the Dairy Forage Research Center, there are other ARS locations that are very key to our research. I mentioned earlier the development work that went into Harv Extra and the reduced lignin products. The Plant Science Research Unit at St. Paul was one of the main drivers there. Hans Young, who was a longtime a scientist there, biochemist, and forage nutritive value researcher, was one of the principal factors there in developing that. Then we have locations in Lexington, Kentucky, with the Forage Animal Production Research Unit, the Pasture Systems and Watershed Management Research Unit in Pennsylvania. All of those are brought to bear also with forage-related topics, and I would encourage you to reach out to their scientists for speaking engagements in the future to kind of get some updates from their research units as well. And by the way, as we were developing this, I was talking with Kim, and we were talking about, do you all need to be reimbursed for anything? Well, we're cheap dates in the federal government. You didn't have to pay any extra for my speaking today. If I was back in my extension specialist days, I would charge a little extra to come out of state, but in this case, I'm a pretty cheap date. So what's next? Where are we going with our center in the future here? Well, the next steps here are to replace some of the vacancies that we have. We've had a number of retirements, but we've been able to fill a lot of those already. We still have about 3 that are ongoing. We have a current vacancy in the cell wall research unit. That's going to be focusing on alfalfa plant physiology and some new products there. In the dairy forage research unit, we are still looking for a research leader there. We've conducted a second round of interviews there and hoping to make a decision on that soon. And then we have a vacancy that we just filled. Actually, it's still in the process of being filled. They haven't officially started yet, but looking forward to having that grazing systems research position there filled soon. Now, right now we have a position open in cell wall that will focus on alfalfa-based diets in dairy nutrition. It's listed under cell wall, but actually in the process of doing this, we're going to be moving that over to the dairy forage research unit. And so really excited about, again, adding another level of dairy nutrition to our research. And I just found out actually earlier this month and today, actually late last night, I received the actual direction of how we need to proceed with 3 additional SYs. So we're going to be up to 25 SYs, hopefully by the end of at least by this time next year. Hopefully we will be up another 3. So I'm really excited about that. In addition to those scientists, we need to be able to fill and support technician positions that will be able to come alongside those scientists and really help them conduct their research. We're also always looking for capable collaborators. We have a number of collaborators across the country, actually about 22 research institutions across the country right now, and a number of international collaborations as well. One of the primary priorities for us is a new dairy. Our dairy that you see here pictured is 40 years old. It was built in the late 1970s, early 1980s, and it's showing its age. It is starting to really deteriorate, and frankly, it's no longer as representative of the modern dairy system as we would really like to see. If you can imagine the change that has occurred with the size of the animals in the past 40 years. Holsteins used to weigh 1,400 pounds, and now they're 1,700 pounds, and often in many cases. So drastic changes there have occurred over the years. So that's our number one priority moving forward. We fortunately have been able to get funds appropriated for that new facility, and we're in the process of beginning the design. But one of the main reasons we're trying to get away from this current dairy, as you can see, it's right along the Wisconsin River. It's about 300 feet actually from the Wisconsin River and about 750 feet from the manure storage. So really concerning there. We also need to get away from that river because of the ventilation issues that we have. We have some real challenges there with cow health, and getting away from that river will really make a difference for us. We're also surrounded by housing. Within about 1,000 yards of this dairy, we have I think it's 85 houses right now. And these are not, this is not low rent district. This is the high rent district, right along the Wisconsin River and Lake Wisconsin. So we have some challenges on that front as well. So we're trying to isolate ourselves a little bit more from that. And the reason why we are located here, and if you can see my laser pointer, that's where the current dairy is located. And our crop fields are all here in what used to be the Badger Army Ammunition Plant. This was a U.S. Army facility. We were able to farm that land, but we couldn't build on that land because back then they were building bombs, literally. They were building munitions for the U.S. Army. And so from a safety standpoint, we weren't allowed to build any buildings over there. That's why you can see all these roads and everything. They had roads and bunkers for storage of the ammunition and the munitions that were developed there. So in 2004, when they shut down the Badger Army Ammunition Plant permanently, there was about 2,000 acres that was deeded over to the U.S. Dairy Forage Research Center, and this is what's outlined here. We're proposing that our heifer unit will remain where the current dairy is located, which will principally be a grazing unit. And then we will move the new dairy to more of a centralized location here to be able to get into a little bit easier way of getting our forages in and out. It's also going to put us closer to that cropland base. We don't need to cross major highways, which has been a major safety risk for us, and a greater labor efficiency too. Plus, we're going to be bringing in some robotics. And so we're really looking forward to being able to conduct the next generation of research there. I know Michigan State has had a great level of success there with their robotic dairy. And we're looking forward to bringing in our own spin to that too, and looking at it from a nutrition standpoint. The original dairy was sized for 320 to 325 cows, and we've had as many as 425 in there. So you can imagine space gets really tight. Our tentative goal is to design it for 450, and this will allow us to have a greater flexibility in our research goals. And then it's definitely going to improve the design, fair, and well-being too, which is a major priority for us. A happy cow is a very productive cow. Another avenue that's really the next frontier for us is cover crops, and looking at ways to integrate cover crops, not only for their ability to hold the soil and capture more nutrients, but also to be able to utilize them as a forage crop too. Of course, the principal goal here is to be better stewards of our land, to build the soil, to capture nutrients, and mitigate some of the nutrient loss that occurs there. And so we hope to be able to predict the role of cover crops better in preventing nutrient loss and improving yields, and comparing better application methods and recommending what to do in those events. We want to be able to minimize the impact on the environment, of course, and so coming up with strategies here to do this. Here's an example of some research where this actually is from Ohio, some work that was collaborative work in Ohio, where they were looking at a dragline system and what time they could be putting that onto corn silage. We're also very busy in monitoring contaminants, not only nutrients, but also things like bacteria, viruses, and other pathogens. In fact, our scientists haven't really participated specifically in COVID, but they've informed or they've educated other scientists who have been looking at COVID spread and wondering if there is movement of that within groundwater systems, and looking at nitrates and other contaminants that might be in our groundwater systems. This is an example one. This is right on the edge of the Door County Peninsula. And this same topography, the same physiography, if you will, that particular parent material, that shelf actually goes all the way over to Niagara. I think it's called the Niagara Escarpment or something like that. But it arches up through Canada and all the way over. Maybe even it affects the Upper Peninsula as well. I'm not exactly sure, but I know it goes into Canada and over into New York State. And monitoring how those nutrients move through those soil profiles and down through the bedrock and into the groundwater. That has been a major focal point for our research going forward. And also being able to differentiate between human and bovine sources. That has been a key issue. One other aspect of that, and I hope that maybe sometime later we'll get a chance to talk a little bit more about this in depth, but Dr. John Grabber in our research center has been developing a system by which he can interseed alfalfa into corn silage and be able to get a jump start on the alfalfa cycle. So that really has made a huge difference in improving the timeline there and the rotation between corn and alfalfa. So getting back to our integrated research platform, I just want to highlight again the nature of that, and the role that we play here is to try to integrate all of these moving parts, and so that we can see the full puzzle picture here. And again, our mission is to lead the world in that integrated dairy forage systems research. And so if you have any questions or comments about our research, I would be happy to answer them now. Hopefully we've got a few moments for some questions.
Dennis, I haven't seen any questions come into the chat so far. So as far as I know, I think we're in pretty good shape. If there are questions, please type them into the chat and we'll make sure and get those asked. Dennis, one of the things that I wanted to ask you was, as you talk about adding people to your research staff, how long does it take for those staff people to really gear up and be able to produce information that the farmers can use down the road? Mm-hmm. Could you address that for us?
Yeah, that's a great question. And I have to give the extension answer, which is it depends. If I go back to my extension days and channel my former self, it does depend, and it depends on the subject matter. So for many things, our researchers are very well outfitted. So if it's a subject matter which we have the equipment and maybe some continuing research in, maybe it's going off on a slight tangent that's going to fill in some of the additional details. You know, in that case, it's a really rapid turnaround, really quick response. In new avenues of research, that might take as many as 3 to 5 years before we really have a robust set of new best management practices to bring out. A little further down that road might be things like breeding efforts. Breeding efforts are notoriously slow, and it takes a long time to bring something that's ready to go to market, and then the process of bringing it to market, maybe even another 2 or 3 years in addition to that. So it just depends a little bit on the direction that we go. Um, and that direction I want to point out is not just from the center director. I mean, I have some influence on that, but principally we lean on our stakeholders. We lean on folks who are active in the industry, and colleagues around the country to let us know what are some of the holes, where can we best plug in to be good collaborators and to take this this ball and run with it a little further. So that's really the aspect. It just depends on what that area of research is as to how quickly that would come to fruition.
Another question that came in is tied to alfalfa interseeding into corn silage. Could you give us a little bit more detail on that, please?
Yeah, I would love to. And what I would first do is encourage you to check out an archived video. We have started doing our own set of webinars 2 times a month. So the first Wednesday and third Wednesday of every month at 3 p.m. Central Time, we hold a webinar. And Dr. John Grabber actually just presented his maybe a month or so back. That information is freely available on our website. But basically, the mechanism is you would plant into, you would start with your corn silage crop. You would get it planted after shortly before emergence. Then you come back and you would plant your alfalfa right over the top of that. You could either plant it in parallel with the rows of the corn, or you could put it at a perpendicular, however that might be. But then the key here is, as that canopy closure occurs with the corn, as you get close to the V6 to V8 stage or so, then you would come in with a plant growth regulator. Apogee is the trade name. And by the way, any mention of trade names, I have to give this disclaimer, is not an endorsement of the particular product. That is a product that does work. It's the only product that's labeled for that particular purpose at this point. But basically what that does is it shuts down the alfalfa, causes it to really further develop the root system, but not really compete that much with the corn silage. So the corn silage yield would be taken off at a normal time. It would be about maybe 5% yield drag on the corn silage. It's really a relatively low amount. And then basically you're skipping the establishment year of alfalfa. So you could actually get some alfalfa off of it by the end of the year, but then the next year when you start, you're already at year 2 alfalfa yields. You don't have that establishment year lag in alfalfa yields to deal with. So the economics of this has been published as well. Dr. Grabber and colleagues at the University of Wisconsin showed that it was very advantageous from an economic perspective. And again, all those details are available in that webinar that's archived on the website. I encourage you to dig into that. And in fact, I'll try to here in a moment share the address for the website. I just realized it's not on my final slide here.
Another question that's come in is tied to the human and bovine bacteria sources in the groundwater. The question is, have you done any work with scent-trained canines to accomplish this?
No, we haven't. That's an intriguing idea. Most of these are well water samples that we're looking at to try to determine, the content, the pathogens that might be present. And my sense is to really get the kind of level of detail, we would want to not just have a plus or minus, but a quantity, to understand. Actually, we have a scientist who focuses on risk assessments, and quantifying that is very, very important to be able to determine if there is that enough to be of concern or not. And conducting those risk assessments are a real part of our mission, is to ensure the safety of our water supply.
Great. Another question asking a little bit about reestablishing mixed grass and legume grazing pastures. Are you doing any research on that aspect?
Yes, Jeff Brink actually did quite a bit of work on that over the years. And again, I've got some archived information there from a previous talk. And by the way, I do, since we are doing a lot of these Zoom, and I haven't talked to Kim or Gary or anyone else, but I hope that maybe my Bailage talk this afternoon, if you don't mind, I'd like to record that myself to be able to put it up on the website. That's one we don't have. But there is a little bit of information on that on our website from some work that Jeff Brink did. Let me cut to the chase on that. One is, yes, you can make a huge difference in, if you start with a mixture of various components of your pasture, and you're trying to get some improved pasture going there. Yes, you can make some huge changes in the dynamics there, but if you go ahead and you treat it basically the same way that you were treating it before, within 3 to 4 years, it's going to revert back to what you had to begin with. So by renovating your pastures, that's not the be all end all. If you don't change your management, you're not going to end up with an improved pasture. So grazing height, grazing residual, fertility management, strategic fertilizing in terms of trying to keep that balance between clover and grasses. All those principles apply. Everything that Kim has I'm sure talked about in various workshops over the years, those are the key things. If you don't do those best management practices, you're going to revert right back to the mess that you started with. So I would encourage you to chat with Kim about that for specific recommendations in Michigan. But yeah, there have been some work on that, and there's some good seminars and good archives on our presentation page to provide that.
A question about research on the debate in agriculture, and specifically about the cow's contribution to greenhouse gases. How is your center involved with that controversy?
Well, we are heavily engaged in that research, and actually, I can't speak to what conversations that are ongoing right now, but I can tell you that those conversations are extensive and many at the moment. We are having lots of talk about how we might be able to do more. But currently, what we have set up is an emissions chamber. So we have trials where we have animals in specific chambers, and we're measuring their gaseous emissions, of which methane and ammonia and a lot of other gases are part of that analysis. That has been in place actually for about 12 years now, I believe, maybe even longer than that now that I think about it. Dr. Mark Powell actually started that research, and then it kind of built from there. And right now we're actively using that practically year round. We're hoping to expand that. We want to see more work in that. And actually one of the positions that I had listed there, the precision animal scientist and methane emissions scientist, that position is a new line basically to focus on that particular subject. Then we also have, in collaboration with researchers at UW-Madison at Marshfield, where we're doing a lot more grazing research, We have recently installed a green feed system, which allows us to be able to capture methane emissions in the pasture to see what's happening in the pasture. So we're going to be able to look at this in a broad perspective, and it appears as though there's a lot of interest in the industry, at least, and hopefully that generates some interest in Congress to provide us some additional funds and resources to be able to do more of this research. Right now, a lot of this work is proceeding, and it's sometimes not done in an unbiased way, right? There are some that might have agendas to bring, both on either side of the coin. But generally speaking, someone needs to kind of be approaching this from an unbiased perspective, and we feel like we can play that role.
The last question for us as we get set to transition to our next talk here in about a minute has to do with two things, actually. It's two questions, not one. How do people stay in touch, or how do they stay up to date with research that's going on at the center? And then you touched a little bit about funding. Can you give us a answer in about 30 seconds, and then we'll finish it up these questions.
Well, there are many ways. One is via our website, obviously. The other is to attend those webinars. So each of our scientists is charged with giving at least one of those webinars each year, so that you get an update from each scientist throughout the year by doing so. So really encourage you to check that out. And then we have speaking engagements all over, and of course our scientists also publish in popular press outlets like the Hay and Forage Grower, Progressive Forage Grower magazine that Gary was talking about earlier as perks of membership in your organization. So yeah, there's a number of ways that you can hear more from our researchers.
All right. Well, thank you very much, Dennis, on your overview of the research that's going on at the center.